Alright guys, so I'm going to be going over this introduction to climatographs or climatograms, however people decide to talk about them. So basically what a climatogram is it's going to be the trends of temperature and rainfall in a certain area over a course of a year. So the first thing we need to make sure we do is label the x-axis, January, February, and etc. So that will be the months. So the months will go on the bottom, and I just use the first initial. So January, February, March, April, May, June, July, August, September, October, November, and December. Okay, so we have the months of the year. On the left y-axis, this side right here, we're going to do the temperature in degrees Celsius. And we're going to do that in red. So temp in degrees Celsius. Okay. And on the right side, we have rainfall in millimeters. Rainfall in millimeters. So I'm going to label the numbers in my pen just so it's easier for you to read as you watch this video. So for our temperature, we have a low of 10 and a high of 17. So I'm going to go by 5. So 5, 10, 15, 20. And then for the rainfall, we have a low of 1, but a high of 105. So it's a little awkward. But what I'm going to do is I'm going to go by 15s. 15, 30, 45, 60, 75, 90, 105, and 120. And because they are different y-axes, you can go by different increments. So I'm going to start plotting my temperature. If you notice on the instructions, it says plot temperature using a line graph. So for January, I have a temperature of 10 degrees Celsius. So January, I go up to 10. So I put check. And we'll use the red. Okay. February is 11, so February, go up a little bit above 10. March is 12 degrees, so March, 12. April is 13, so I go up to April. Go a little higher for 13. And I'm just gonna work out the rest, so you can do it fast forward if you need to. October starts coming back down at 16. November, we have 13. In December, we have 11. And then we're going to connect those lines. So before we move on, let's look at the trends. So what we have is the low is going to be, so sorry, this one should be like right around here. So it's going to go like that. All right, so we have our low is around 10 degrees Celsius with our high being around 17 degrees Celsius. So there's not a wide range of temperatures in this location. We have the colder months are going to be our winter months, and our warmer months are actually late summer leading into fall. So it's a little bit different than where we're from. Okay, so it goes up and then it goes right back down. Now we're going to do rainfall. Rainfall is going to be a bar graph, and we're reading from the right y-axis this time. So we look over. So January is 105 millimeters. So I have January, and then I go up to 105 because I'm looking on this side now. So 105 for January, and it is a bar graph. Okay. All right. February, we have 71. So it's going to be about right here. March is 59, so right below here. April is 39. May is only 10. June is 3. July is 1. August is 1. September is 8. October is 10. And November jumps to 50. And December is 72. Okay, so if we look at the trends here, we have the winter months are wetter than the summer months. Summer months tend to be much drier. So also a correlation, it seems to be as the temperature is lower here, the precipitation is higher. If you notice that right there. So that is how to build our climatogram. All right, so the first question, you're referring to the graph on the first page, so I'm going to skip that one for now, but I'm going to do number 2. What was the approximate temperature in January in St. Louis? So this one is slightly different. So we have the temperatures in Fahrenheit and Celsius, so you can compare those. We still have the precipitation on the right side. Instead of the month's names, it has the month number. So one is still January, then we have February, March, April, May, June, July, August, September, October, November, and December. So when it wants the approximate temperature in January in St. Louis, we're looking at this line right here. Okay. So in January, the temperature is slightly below 0. So we could put approximately -1 degrees Celsius. Number 3, we're looking at the greater range of temperatures. So to find the range of the temperature, we're going to look at the lowest temperature, which is going to be around this area, and the highest temperature, which is going to be about this area right here, and we subtract them. So the highest temperature is around, let's say, like 26, 27 degrees Celsius, and down to -1. So that is over 20 degrees difference. So -1 to 26, so that's about 27 degrees difference. Whereas Monterey, we go from 10 to 17, which is only a 7 degrees difference. So the greater range of temperatures is going to be St. Louis, Missouri. And then location has a greater range of rainfall. We look at the difference between our smallest rainfall, which is going to be about 50 millimeters, up to a little over 100, so it's 50 millimeters. And here we range from 1 to 105. So Monterey actually has a greater range of rainfall. Now number 4 gives some reasons why there are significant differences in temperature and or precipitation patterns between the two cities. So one thing that you may not be familiar with is Monterey is right beside an ocean, and so when areas are close to oceans, they have a more constant temperature pattern. That is because water has a high specific heat, so it takes a lot of energy to raise the temperature of our water, so it absorbs a lot of that heat from that land, so it keeps the temperature pretty constant. Whereas St. Louis, Missouri is landlocked, and so it does not have that advantage. And there are also different distances from the equator, which causes changes in patterns of temperatures. And I hope that is helpful.